friends. I am Dr. Jagan Mohan. See, we have been discussing about the methods of power generation and the different kinds of power generation. And can anybody tell me what is the cheapest source of power? So the cheapest source of power is the hydropower. What is the cleanest method of producing the power? Is the hydropower. So here we are using the potential energy of the water which is stored in the dam to generate the power. So for generating the power, we need dams. So if you come to the dams, so today our topic is genus of dams. So what are the patterns? What are the different patterns of the dams? See, the dams are not new things for us. We have been constructing the dams from very ancient times. If the historians say the excavations reveal, the proofs reveal that the people used to construct the dams, the rivers, for the reservoirs, for different purposes. See, since the starting of the human civilization, so parallelly so many civilizations have started. But we say that, so since the man came from the Homo sapiens, so they have lived in the forest. But they flourished, they started developing enormously only at the banks of the rivers. See, these rivers, in some seasons, they will create floods. Okay. After coming to the agriculture, only the human population has exploded. So for this agriculture, the water resource is very, very important. So that's why so many civilizations, if you say the Indus Valley civilization, so it has flourished based on the river Indus. If you go to the Mesopotamia, it has flourished based on the river Euphrates and Tigris. Nile, Egyptian is Nile. So like that. So only the civilizations which has expanded based on the rivers have started the journey and able to live even today. But some civilizations which have started without the strong foundation of the rivers, they have vanished because of the lack of the water. So these rivers providing so many agricultural and business things. So, but the rivers will not be unstable. Always they will not be unstable. So there will be floods and famines. So the people started constructing thinking that something which should be essential, so that we can store the water during the famine, and we can stop the destruction of these rivers during the flood areas, during the flood times. So if you observe the environment, if you observe the atmosphere, if you observe the agriculture track, so the 1 year the rains will come properly. Next year, some years, some 1 or 2 years, it will not come. There will be less rains. After 1 2 years, there will be more rains. So causing the fluctuations of water supply. Similarly, causing the fluctuations in the flow of the river flows, the level of waters and the rivers. So that the people started making some constructions with the technology, and some people after, so this dam has protected in both times, floods and famines. And if you observe in India, the dam the Kalandi Dam, so which was constructed by the Cholas in Tamil Nadu, is the ancient, oldest dam which is working for even today. The Kalandi Dam in Tamil Nadu. So they have found how they can control these floods and famine. So they have concentrated on increasing the area of agriculture, farming more land, taking the unfarmed land into farmland by constructing these dams. So they have diverted to they have constructed the channels and they have diverted. Okay. See, so from the age old practice is that with the dams is that we are using these dams for controlling the floods, for controlling the famine, and for increasing the agricultural farming or agriculture production. So along with this, so we were using this for transportation, tourism, aquaculture, drinking water. So if I am saying a dam, so it is a multi-purpose. So if I am constructing a hydropower plant, so it will not survive only the purpose of generating the power. So it will survive the purpose of generating the power, along with it will satisfy the purpose of agriculture, it will satisfy the purpose of drinking water, it will satisfy the purpose of aquaculture, it will satisfy the purpose of tourism. So if you construct a hydro plant, so it will be beneficial in so many, it is beneficial in so many angles, not only in so if you are constructing a wind power, the purpose is only to produce the power, coal power, all these things. So here what is happening, we are getting cheap power, we are having benefits, another benefits of agriculture, drinking water, all these things, and you are getting the cheapest and cleanest form of power without any pollution. So the dam is the basic need for producing the hydropower. So there are some way of producing the power just with the help of runoff river power production. Yes, it is there without constructing any dam. Just it will use the water which is flowing in the river, the kinetic energy of the water which is flowing in the river, and will produce the power. But the amount of power produced is very, very less when compared to the amount of power produced with the construction of dams with high heads. So if you are able to construct a dam with a high head, so you can be able to produce more power. You can even produce high power. Okay, before that we'll come to that topic of different types of hydroelectric dams. So first of all, we need to know what is a dam. So it is a construction which stops the flow of water on the surface of the earth. So there are different types of dams. So we'll move into that. Okay. I have already told you a dam is a barrier. Dam. So it is an obstruction. It is a resistance which stops. It will stop and restricts the flow of surface water. A dam is a barrier that stops or restricts the flow of water on the surface of the earth. So there are different types of dams. So since we have concrete is recently formed. So before concrete, what they might have been using? Maybe stones. So even before that, so if they are not having that much, if some ethnic groups, some areas where that much of technology also not there to construct with the help of the stones, the blocks, so they might have used some kind of rocks without proper shape or some soil, some mud. Yes, they have constructed. So that is oldest. So constructing with uniform rocks. So if something is constructed uniformly, otherwise if something is constructed with mud or with sand, so that means the technology, the resources are limited. So you can observe even today, if you go to some areas, some remote areas where this technology have not reached, this culture have not reached, you can find the houses constructed with mud, with uniform rocks. Okay, even with that they were able to construct very nicely. So that shows that their power, it is local. So it is not planned by a very big organization. But after that, they were able to construct with bricks, normal bricks. After that, with making a uniform blocks of stones. After that, they have found to construct with the concrete. Before that, mortar. After that, concrete, cement. So for the dam, if you are able to construct with the cement, is very good. So whatever the material, every material in the world which you are using for constructing a dam or in the world, every material in the world, so it will get weak. It will become weak with the contact of water for years, not maybe for some days, for years. In course of time, everything which comes in contact with water will become weak. Only the thing is the cement, concrete. So it will become harder. If water comes in contact with it, it will become harder, more harder. So that is the advantage of construction. So that's why normally we are all using constructing with the concrete. We are constructing concrete dams. So after technology has advanced, so some people has started constructing with metals. Yes. So which metal is good? Which is harder to withstand that much of force, that much of pressure? Another metals are there, but their strength is less. So we can use iron. If you want to use iron, so what is iron? Iron is a strong. Iron is very strong metal until it comes in contact with the water or moisture, at least moisture in air. It will become weak. It will start rusting. So that's why they have found some alloy and they called it as steel. They mixed some metal and they called it as steel. Even that steel dams they have constructed. So based on the height of the dams, high head dam, medium head dam, low head dams. So like this, there are 21 varieties of dams. So if I am saying high head dam, low head dam, medium head dam, means I am concentrating on the head. So why I am concentrating on the head means I want to generate the power. So these, based on these heights, I will generate power. If in my mind the intention is to produce the power, I will see the height of the heads there. So we will see what are the different types of dams. So first thing is masonry dam. So first, this is a masonry dam. So even with soil, they have constructed that way. See, masonry means some unique elements, maybe stone or bricks, individual elements. So with these individual blocks, or we should not call this individual blocks, so they have constructed. So our Nagarjuna Sagar Dam, which is famous dam in India and in the world, is a masonry dam. It is a masonry dam. So they have constructed with masonry blocks. So these masonry dams are also some other dams also comes under this. They are gravity dam, arch dam. So our Nagarjuna Sagar Dam is a masonry dam. So about this, a greatest dam is coming. That is Three Gorges Dam. So everybody might have heard about this Three Gorges Dam. So if you are going to construct this Three Gorges Dam, because of the huge amount of water it is going to store, it will create an imbalance on the surface of the earth, and even the earthquakes will come because of this construction of the dam. Like that, so many environmentalists have opposed this, but they have constructed. So since it is a newly constructed dam, so it is a concrete dam. So it is the biggest concrete dam in the world now. In future, we don't know in future. But in now, as for now, it is the biggest dam in the world. Buttress Dam. And also the Gravity Dam, Arch Dam, Buttress Dam. These dams also we can construct with the help of concrete, but their purpose is different. Their purpose is next thing is the timber dam. So timber dam using with it's so how much long it can withstand? It cannot stand very much long. So it is because it is a timber dam. Okay. So that means in the selection of the material for constructing the dam itself, it is showing that it is the purpose of constructing that is a temporary purpose. That is a temporary purpose. So that's why the timber dam is generally used to construct to meet a temporary purpose. So that means maybe sometimes for diverting for some time, for stopping for some time. So sometimes we have divert in order to construct a main dam. So if the water is flowing, if you want to construct a dam on the river, so if the water is flowing there, so you cannot construct. So first you have to divert it. So after you divert, so no water will flow there. So there you will construct and you will remove this. Again water will be storing in the normal path of the river. Okay. So generally the height of these dams will be 9 meters. Okay. And also some temporarily rubber dams also came now. So temporarily to control the flood or to stop temporary purpose. Even the rubber dams also serve the same purpose. So next thing is steel dam. So this is also a dam which is constructed for a temporary purpose as similar such as the timber dam. So here we are going to use the steel plates. Okay. So the height of these dams is 15 to 18 meters. So the height is 15 to 18 meters. So you can observe in the picture. So this is Red Ridge Steel Dam. So it is there in USA. So it is made up of steel. So, but this is also constructed on a temporary purpose. Okay. Next, you can observe the earthen dam. So in the name itself, it is there. So what you have used. So these earthen dams, you can say reservoirs. Okay. So many villages they will be having reservoirs for agriculture purposes. Normally they will be using the soil. Okay. From the very olden days. So especially in India, we will be using the reservoirs to store the rainwater. Okay. So there are so many big reservoirs also there. Okay. So it is made up of ordinary soil, which is cheaply available. Okay. So if you want to construct it cheaply without very big technology, so no need to make any bricks, no need to make any shape of the rock units. So it is a cheap process. You can construct. And in another situation where, so if you are constructing a masonry dam, so a dam, a rock structure or concrete dam, that soil cannot withstand that much of pressure. So the soil is very weak such that it cannot withstand that much of pressure. So in that cases also you can construct this type of earth dams using the soil which is cheaply available. Next thing is rock fill dam. So in the name itself it is there, using the rocks. So we'll be using the rocks. You can observe there. So if you see this diagram, you will be having total rocks. So many rocks. So such that the water will stop. Small rocks. So in the upstream, so that means the upstream, this side where the water is stored. So we are using the very dry rubble masonry and loose rock fill in the downstream side. So before dam, upstream means before dam. After dam, loose rocks we are going to use there. So and also some amount of concrete we are going to use in order such that the water will not get weak. The water is not going to weak there. So why we have to go for this means, so it is better to construct this type of dam than the earthen dam. So earthen dam will be very, very weak. Okay, rock is somewhat harder, carries more weight than that soil. So it can withstand more pressure. So in such cases we are going for the rock fill dams with small amount of usage of concrete. So it is cheap and best in some areas. And similarly the gravity dam. See, only with the strength of that construction, not any other supports. So mountain supports, all the supports. So just with the construction, it is going to stop the force of the water. So a gravity dam is a structure which resists the external forces by its own weight or self-weight. No other support from the, generally where we are going to construct a dam. If you are constructing in the mountains, so larger part is covered by the mountains, so this part we are going to construct a dam. So these mountains will give support to these dams. So, but this case it is different. So it is a structure which resists the external forces only with its self weight. So it is normally a masonry or concrete. Normally, yes, under the gravity dams, you can construct concrete or masonry because only with that, no other support means. So this is very strong. So we have to, because the only support is that its own weight to withstand the forces. So we have to construct in such a way that its foundation is strong with rock foundations. So we have to take care while constructing a gravity dam. If other support is there, that's a different case. So this is a gravity dam. You can observe a Grand Coulee gravity dam, which is there in. So you can observe there. So it has not got proper support from the sides. You can observe. If you go to the Nagarjuna Sagar Srisalem, it has got support from the neighboring hills. So that is a different case. And next is the Arch Dam. It is the Arch Dam. So we are going to construct. So if you observe this dam, so what is the shape? It is straight. Otherwise, you go for this rock fill, normal, earthen normal, steel dam normal, timber normally, generally straight. It will be generally straight. Concrete dam, that 3 versus dam, straight. So river is flowing like this, just perpendicular to it. They have constructed straight construction. Normally that Nagarjuna Sagar also, but this is a different case. So arch dam. So we are going to construct in the convex shape. So that means we are diverting the force to the sides. We are diverting the force to the sides. In the sides we will be having the hill supports. So with this of convex shape, so we can stop so much of water. So this can withstand so much of pressure than other, because so it is diverting. So normally this type of construction will go normally where we are having that support. You can observe. So it has taken the support from neighboring hills, and where this length is small, where the length is small but the height is small. The height is more. So more height means more pressure. So high head, more height, more pressure, more head, and more power we can generate. Okay. So such cases we are constructing the shape of U shape or half circle or convex upstream. Okay. So generally we will construct this type of dam with a masonry or concrete. So since the we are constructing this type where there is less width is there, so normally the less material is required to construct than the normal dams. So these arch dams are generally preferred for narrow valleys. So that's why the width will be small. So it is economical. So it is, the construction of this type of dam is economical because the width is small but the height is more. So we can store more water and we can generate high powers. So that's why in that cases where the areas of narrow, where the geographical condition is suitable with a narrow width, so we are going for this type of arch dams. You can observe here. So this is convex shape. Next thing is the Buttress Dam. Okay, you can observe here. So this buttress supports. So straightly they have constructed here also, but this side they have given the buttress. support. So how much width, how much more width, that many more buttress. So buttress dam consists face slab, buttresses and base slab. Okay. So this side where the water is stored, we are calling it as face slab, and another side we are calling it as base slab, and we are the supporting structures we are calling it as the buttresses. So it is the dam is supported by, since the dam is supported by the series of buttresses. See how many buttresses are there? 1, 2, 3, like this. We are calling it as the buttress dam. So this dam you can so now generally it will be straight. So if you want, we can go on a curved structure also, curved shape dam also we can take. So for this, so if it needed, we can provide a buttress here also. So if the path is wide, that will become a buttress dam. So generally, why we need, normally everywhere we have constructed, but we have not given this type of buttresses in other type of dams. So we are giving here means the soil is weak there. The foundation soil is very weak. Okay. So this is the Daniel Johnson Buttress Dam in California, in Canada. Johnson Daniel Buttress Dam in Canada. So these type of buttresses you can also find in big constructions, not exactly similar like this. Next, embankment dam. So we can call some dam as an embankment dam. So if it is made with a similar type of material, soil or rock, same type of material, same type of rock, and same type of soil. Okay. Generally, we'll be going for mix. So same type of soil may not provide very good strength. So we'll be going for soil which is more strong like that. Generally, we'll be going for different types of soil or masonries, but some rare cases we are going to construct like that. Okay, that we are calling it as embankment dam. That type of dam we are calling it as embankment dam. So next thing is storage dam. So this purpose only for storing the water, especially during the rainy season, and using for the irrigation and water supply. And also we are going to use this for the power generation. Next thing is diversion dam. Similar. So the timber dam, steel dam also works as the diversion dam. So if you want to construct, so the river will be flowing, and if you want to construct a dam across a river, so if the water is same like that, you cannot construct there. For temporarily, you have to divert this water. So for that purpose, we can use the timber dam, we can use the steel dam, or we are calling it as a normal dam for diverting the water. You can clearly observe here. So it has been diverted, and after the work is completed, we will remove this dam, and the river will flow in the normal direction. And detention dam. So only for detention. So what is detention? Only for controlling the floods. So this dam is used only for controlling the floods. That's why it is called as the detention dam. Debris dam. So if the water, so generally if a river is flowing, so it will take so much of debris along with it. So finally we will only get rocks, will be left only with the rocks and the sand. So if you want to control this debris, we are going to construct a debris dam where we can retain the debris of the river water, sand, gravel, driftwood. Okay. So the water on the downstream side of the debris dam is clear. So if you construct a debris dam, so after the debris dam, all this will come: sand, gravel, driftwood. So after this debris dam, only a clean water will be flowing, and the remaining thing will be stopped at that point. So that is the debris dam. That is the debris dam. And coffer dam. So this is also a one type of diversion dam. Okay. Which is constructed to divert the. So diversion dam is normally a temporary dam. Okay. So this is also one type of diversion dam. You can easily understand. So here we have to construct. So it is diverted. Hydropower dam. So if you want to produce the hydropower, it is a hydropower dam. They are divided into three categories. Majorly, they are divided majorly into hydropower dams are majorly divided into three categories, that is low head, medium head and high head. So next, the overflow dam. So overflow dam is the dam. So some amount of water is stored. So if excess of how much amount of water is there, so it will allow the water to pass through its crust. Okay, flowing on the upstream. So after that, the water will be flowing. Non-overflow. So this will not, normally it will not, after it, the amount of water, whatever the amount normally comes, normally will be there, that amount of water also comes. After that, excess of water comes also, it will not allow to overflow. It will never allow to overflow. Only very rare cases, if we think that because of this huge amount of storage, this may dam get damaged. In that cases, only release some amount of excess water, which is excess than the strength of that dam. Okay, with the help of a spillway. Small dam. So it is a small dam. Its capacity is 0.5 to 10 MCM, million cubic meters. So it generally will be 7.5 to 12 meters. Its head 7.5 to 12 meters. And medium dam, so if it is from 12 to 30 meters height, so the head, so it is called, we are calling it as the medium dam, and its capacity is from 10 to 60 MCM. A large dam, so if it is above 30 meters, so if the height of the dam is above 30 meters, not below 30 meters, above 30 meters, so that dam we are calling it as the large dam or high head dam. So its capacity is normally 60 MCM. Okay. So thank you for listening. I think you have got some knowledge about the different types of dams. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.